All right, so in this section, 7.6, we're going to be solving equations involving radicals. So we're going to start with this little warm-up. These are all just square root equations, which we have done before. So if you recall, let's do a nice green color. I feel like I don't do green a lot. If you recall, in order to solve a square root problem, you just need to get the square root alone, kind of like it is in number 1, and then square both sides. So we have square root of x equals 8. So if we square both sides, so square root of x squared equals 8 squared. The square root and the square cancel out. So then we have x equals 8 squared, which is 64. Okay, and then number 2, we want to get the square root of x alone. So we'll subtract 4 from both sides, and then we have square root of x equals -4. And now we can square both sides. So square root of x squared equals -4 squared. And it doesn't matter that it's negative because we're squaring it, not taking the square root. So then we have x equals -4 times -4, which is 16. Third one, the square root is already alone here. We can't take that 4 out because it's stuck underneath the square root. So we're going to square both sides like this. So square that equals 5 squared. And then the square root and the square cancel. So we're left with x plus 4 equals 25. And now one more step to get x alone. We need to subtract 4 from both sides, and x equals 21. So for this problem, just remember that if something is underneath the square root, you can't take it out until you get rid of that square root. All right, so let's start with some different radical equations. So this one we have a cube root, but it kind of works the same way. We want to get that radical alone, so we'll add 4 to both sides here. And then we have the cube root of x equals 4. And just like before, how we squared it to get rid of a square root, we're going to cube this to get rid of a cube root. So we'll go like this. We have cube root of x, and we're going to cube that equals 4 cubed. So then we're left with x equals 4 times 4 times 4, which is 64. And that's it. So for this one, we have a 4th root, but we're going to do the same exact thing. We want to get the radical alone first. So we subtract 5 from both sides. Then we have the 4th root of 3x equals 6 minus 5, which is 1. And now we have the radical alone. Remember, we can't do anything with the 3x yet because it's stuck underneath that radical. So we're going to raise this to the 4th power since it's a 4th root. So that's what we do for all of these. You raise it to whatever root, the same power. So this is the 4th root, so we raise it to the 4th power, equals 1 to the 4th power, which is of course just 1. So then we have 3x equals 1. Divide by 3 on both sides to get x alone. And we have x equals 1/3. Okay, next page here. So those were roots. We can also solve equations that have radical exponents. So this is going to make us remember one more thing about fractions. So first thing you want to do is get the term that has a rational exponent alone. So in this case, we want to get x to the 3/2 alone. So we're going to do that by dividing by 2, because that 2 is not raised to the 3/2. It's only the x that's raised to the 3/2. So then we have x to the 3/2 equals 250 divided by 2, which is 125. Okay. And so now we need to remember how to undo a fraction. So the way we undo a fraction is by multiplying by the reciprocal. So um, that same idea applies here. We're going to raise this to the reciprocal power, because when we do that, when we distribute this 2/3 to the 3/2, they're going to equal 1 because they're reciprocals of each other. So that's how we get rid of a rational exponent. We multiply it by the reciprocal power. Then we have 125 to the 2/3 power, because we have to do the same thing on both sides of the equation. So then we have x equals 125 to the 2/3 power. Let's do that on a calculator. So we'll go to our Desmos scientific calculator here, and we'll do 125 raised to the 2/3 power, and that is going to give us 25. So x equals 25. That's not the same color. Interesting. All right, so let's do that same thing over here. So first we want to get the x to the 4/3 alone. So I'll add 5 to both sides. So x to the 4/3 equals 11 plus 5, which is 16. And the way we're going to undo, we'll get rid of this rational exponent again, is we're going to raise it to the reciprocal power. And we need to do it on both sides, like that. So then we're left with x equals 16 to the 3/4 power. And let's go to our calculator to figure that out. So 16 raised to the 3/4 power is 8. So x equals 8. All right. Next type of problem you might see. So these are just slightly more complicated. We've got a lot going on here. We have two things underneath the radical, two terms. We also have this +2 over here. But it's the same concept as before. We want to get the radical alone first. So subtract 2 from both sides. And then we have the square root of 4x minus 7 equals 3. And then the way we cancel out the radical is, since it's a square root, we're going to square both sides. Remember, you can't do anything with that 4x or the minus 7 yet because it's stuck underneath the radical. So now that we've squared both sides, we have 4x minus 7 equals 9. And now this is just a two-step equation that we're going to solve. So add 7 to both sides, and then 4x equals 16. Divide by 4 to get x alone. X equals 4. All right, and next one, same idea. We're going to get this radical alone. First, we'll subtract 2 because that's outside the radical. And we have the cube root of 2x minus 1 equals 4 minus 2, which is 2. So now that we have the radical all alone, we can't touch anything inside of it because it's stuck in there. So we'll have the cube root of 2x minus 1 cubed equals 2 cubed. And then we have 2x minus 1 equals 2 cubed, which is 2 times 2 times 2, which is 8. And then we add 1 to both sides. 2x equals 9. Divide by 2. And we have x equals 9/2. Or if you want to write 4.5, that's fine. Next, examples. Finally, if you have two radicals, so in all those other equations we had one radical. If you have two, here's what we need to do. We need to get them on opposite sides of the equation. So first thing is get them on opposite sides. Sorry, I should have written this step before that. So what I'm going to do here is I'm going to add 2 square root of x to both sides. that way, we have the radicals on both sides. So we have square root of 3x plus 2. This we canceled out, and that's going to equal 2 times the square root of x. Now, what we can do is we can square both sides since this is a square root. So I'm going to square both sides. Now we have to be careful with something here. I will tell you what in a moment. So over here, we'll have 3x plus 2. Now over here, we need to distribute this 2 to the 2 and to the square root of x. So this is going to be 2 squared times x. And the reason it's just x is because the square root and the square cancel out. So now we have 3x plus 2 equals 4x. I'm going to subtract 3x from both sides to get all the x's on one side. And then we have 2 equals 4x minus 3x, which is just 1x. So x equals 2. And then over here, we've already got this the way we want it. We have the radicals on both sides. They're both to the they're both fourth roots, so I'm gonna raise each side to the fourth power. So 2x plus 1, x plus 6, both under fourth roots. So we're gonna raise both to the fourth power. And then we just have 2x plus 1 equals x plus 6. And then let's get all the x's on one side. So I'll subtract x here and here. 2x minus 1x is 1x plus 1 equals 6. Subtract 1 from both sides. X equals 5. All right, so you saw all the examples. So let's kind of summarize how we solved each of these equations. So first, solving a radical equation. First thing you want to do is get the radical by itself. So get the radical by itself on one side of the equation. And then after that, what we did was we canceled it out. So cancel out. Let's say we're canceling out the nth root. So whatever the root is, we're just going to call it n. So the nth root by raising it. So we're raising both sides of the equation to the nth power. So that's, in a nutshell, what we did to solve the radical equation. So get the radical by itself on one side of the equation, and then you have to cancel out the nth root by raising both sides to the nth power, and then just solving for x. So then, next thing we did here was we solved rational exponent equations. So solving rational exponent equations. All right, so to summarize what we did, first thing, just like with the radical, we need to get the term with a rational exponent by itself. And then once that's by itself, we raise both sides of the equation to the reciprocal power. And that cancels out the rational exponent. And then of course you just solve for x after that. Oops. One last thing we did was solving equations with 2 radicals. So with 2 radicals. So when we do this, first thing we did was we had to get them on opposite sides. So get the 2 radicals on opposite sides of equation. I'll just write an equal sign, so on opposite sides of the equation. And it's probably very important to note here that they must have the same nth root. Otherwise, this won't work. So they must have the same nth root. So once you do that, you have both radicals on opposite sides and they've got the same nth root. Then you just raise both sides. Both sides of the equation to the nth power. And then just solve. So raise both sides to the nth power and solve. And that's it for solving radical equations. And